Okay, let's take a look at this example here. Now, you might remember from your micro econ class or your accounting class that for a factory for production, all the costs can be categorized into two different categories as fixed costs and variable costs. Now, fixed costs are things like rent, right? Which does not depend on how much you are producing, right? You have to pay the rent for your property, for your factory, regardless of how many units you are producing. And then there are other things like variable costs, which does depend on the quantity, right? So such thing as labor, right? Labor or material. Okay, so one of the very useful thing about regression analysis is its ability to estimate what is the fixed cost and what is the variable cost. So here we have two variables. One is production volume quantity, and then one is the total cost. Right, so this total cost here includes both fixed costs and variable costs. All right. Now, once we run the regression analysis, then we're going to be able to make an estimate of what the fixed cost is and what the variable cost is. Now, to do this, we're going to input these data into statistical software. Here, we're going to use Gradle, but you're free to use any software you like. Okay, so now that we have Gradle, let's go ahead and open up Gradle here. And what you want to do is go ahead and go to File and go to New Data Set. Okay, we don't have the data file for this problem, but that's okay. There's only 6 observation here. So that's going to be we can input this very quickly. Now, when you input this, you want to go to cross-sectional. Don't worry too much about what these means. We haven't covered these in details in class yet. But for now, if it's let's say this is one factory, so that's going to be cross-sectional data, right? If your data set is across time, then you will want to select time series, okay? But that's not what we're dealing with here. So now observation here. So here we go. We'll start input data value. So go to apply. Now first you want to enter the name for the first variable. So just look at your handout. Right here we have units. Right, so that's our volume. Okay, that's our first one. And then we're going to go ahead and input the data here. Okay, so I'm just inputting the data from the worksheet. First one is 400. Okay, and then the second one 450, 550, 600, 700, 750. Okay, now when you're done here, go ahead and click check, and then there you can see it pop up. Now I have a variable name here, units. Okay, I want to add another variable. You click on add. Now, so don't click on add observation. If you click on add observation, it's going to create a 7th row here. So I want to add another variable into my data set, and this variable is going to be total cost. Let's just call it TC. Okay, total cost. Okay, and then here I have total cost and 4,000. Okay, and I noticed that I am missing an observation here. Let me check. 450, 550, 600, 700. Oh, yeah, 750 for the last one there. Okay, and here we don't need a spreadsheet program. Right? We can see this, see the files laid out pretty nice and neat here. Okay, now once I'm done, I just click check, and here we see that it pops up here. Now, once I'm done with that, then I can go ahead and click model, go to OLS. That is the method that we're going to use. Okay, OLS. I want to estimate cost. Cost is going to be my dependent variable. So put that in there. And then I'm going to be using units, right? So quantity here. And then finally click OK. And there it is. Now go ahead and write down the coefficient. So these are the two coefficients, and go ahead and copy that down on your paper. And that is going to be your B1, B0 and your B1. So now that we have our estimated parameters, we can go ahead and write down our estimated regression equation. So I'm going to use TC as my total cost. Put a hat on it to represent that is the estimate, and it equals plus 7.4. And here we're going to have units, which I'm just going to put Q for quantity. So that's my estimated regression equation, and that's gonna given the quantity or the number of units, that's gonna give me an estimate of the total cost. So now we can see this. So B, what is the variable cost? So here that's going to be this here. It's going to be the slope, because this is, so as my quantity increases, right, that this 7.4 sorry, for every unit increase is going to increase my cost by $7.40. So we're going to say, so my variable cost is $7.40 per unit. Right? So that's my variable cost. And might as well, by the way, fixed cost, right? My fixed cost is going to equal 1,342.11. Okay, that means, right, if quantity is 0, meaning if we don't produce anything, then what's my total cost? It's just going to be 1,342, right? Think of that as the rent, maybe taxes, right, fees that we have to pay no matter what. Okay, and so that is going to be that is our estimate. Okay, now let's go on to C. Okay, the coefficient of determination. So remember, coefficient of determination, that is our R square. So we're going to go back to our Gödel output to take a look at that. So remember, our R square, our coefficient of determination is SSR divided by SST. Okay, now to get that from Gödel, we can see it actually right here. Coefficient of determination, that is just R squared. So that is a 0.932. Now, if you don't have this here, you can also go to analysis, okay, and go to ANOVA. ANOVA stands for analysis of variance. Click on that, and that is going to give you the SSR, SSE, and the SST. Now, SSE, the sum of square. So in your textbook, the reason why it's called SSE is sum of square errors. For Gödel, they call that residual. So residual means error. They're the same. They represent the same thing. Okay. So here, right, we have SSR. So this is this is SSR. Now, how do you read this? Right, this is 3.12428, right, times e to the positive 6. That just means you multiply by 10 to the 6th power. So you add 6 zeros there. Let's go ahead and write that down, and then I'll show you how do I deal with that. Okay, so that when you copy down what we see on Gödel, that's just all this means, that E times plus 0.006, I just mean times 10 to the 6th power. How do I convert it? Well, you remember from basic algebra, right, that when you multiply by 10 to a negative power, you just move the decimal point. So here we go, going to move the decimal point to the right 6 times. 1, 2, 3, 4, 5, 6. And so basically we add a 0 here, so that means it's 3124280. Okay, now we also need SST, so go back to Gödel and then write down what SST is. Okay, so we can see that there. Okay, do the same thing, move it 6 times. 1, 2, 3, 4, 5, 6. So we're going to add 30 here. Okay, and that's my SST, and that's my SSR. So now I can calculate my R square. Okay, so that would be two. Okay, so this is exactly what we expected. If you go back and look at Gödel, right, this is exactly what R squared, that's the exact number that we got. Okay, so let's see what this number actually means. All right, so read the question again. We compute the coefficient of determination. And now we can answer the question, what percentage of the variation in total cost can be explained by production volume? Okay, so we can say that 93.2%, right, of total cost, all right, is explained by production volume. Or units or quantity and so on. And that's quite a lot, and of course that should make intuitive sense, right? If you're building something, most of your costs is going to depend on how much you are actually producing. Finally, let's take a look at part D here. D says the company production schedule to show 500 units must be produced next month. What's the estimated total cost? So first, let's go ahead and plug in. So that what it means is Q equals 500. So let's plug that in into our estimated regression equation. Okay, plug that in, and you get $5,042.11. Okay, but what does that actually mean, right? So this is a prediction. So we can view this number in one of two ways. So first, right, that is the predicted cost, right, or total cost, I should say. Let me just emphasize that. Predicted total cost for producing 500 units next month. Okay, an alternative or very closely related interpretation of this is that this number here is the average, or I should say more accurately, expected cost for producing 500 units. Okay, there's a very small, there's a subtle difference between the two. Here is prediction. Right? If we are producing 500 units, right, how much? What's the total cost that we can expect, or we should expect? Yeah, that would be this number here. Now, what this number also represents is, on average, if you are producing 500 units, then sometimes it could be, sometimes it could be higher than $5,000. Sometimes it's cheaper than $5,000. But overall, the average cost of producing 500 units is $5,052.11.